Today we're learning about systems of inequalities. All right, what does it mean when it says systems?
I don't know. Something to deal with the system. I don't know.
We've been doing systems of equations for the past a whole bunch. You just took a benchmark on systems of equations.
Oh, is it like
I got nothing.
Go ahead, Taya.
The way you do a problem?
Not the way you do it. What's the difference between when we were solving equations before and what we've been doing this last chapter?
We're replacing things.
We're replacing things.
We're doing other weird stuff.
Because we're solving for how many variables? Two, because there's two equations. That's what a system means two equations. So now what we're going to do is we're going to solve two inequalities at the same time by graphing at the same time. Do you remember before? Do you remember before when we were graphing and we were shading? Like one side, top or bottom, above or below? That's what we're going to be doing this time. All right, so everybody write it down. Example 1. X minus 2y is greater than negative 6, and y is less than 3x. All right, now these don't look like y equals mx plus b, so let's change them first. How do I change this top one?
gotta get y in front?
Got to get y by itself, so what should I move? The x. I'm going to subtract x on both sides. So now I've got negative 2y is greater than, I'm going to make this negative 1x minus 6.
I'm sorry, I'm going to interrupt your class for a second so I can show you this.
And then what? How do I get y by itself? Divide by negative 2.
It's okay, Kelsey.
Looks beautiful.
I'm not
Thank you.
guessing no more, okay?
You're very welcome.
Okay, what happens if you divide by a negative number? Switch the sign. That's y is less than. This is going to be a positive 1/2 x. And then what's negative 6 divided by a negative 2?
3.
Positive 3. All right, so this is one equation we're going to graph. The other one looks like this, but what's the y-intercept of this one?
1.
So I'm just going to write plus 0 over here. Okay. All right. So now what we're going to do is we're going to flip it over and we're going to graph both of these in the same graph.
Oh, shoot. I wrote it on.
You want? That's okay. All right, I'm going to keep this up here so that you can see the equations we're graphing as we graph them. All right, so example 1, make one set of axes. How much are you throwing away, Abby?
Oh, shiz. I literally just focus on organizing. I'll redo it now. So far, none.
Okay, so let's graph
I know what to
this
do.
one first. Tell me.
Okay, so you for the 0, you go at 0, and then you go up 3 over 1. Up 3 over 1.
Okay, I'm going to put this over 1. Is this a dotted line or a solid line?
It's a dotted.
That's a dotted line. Good job.
What?
Because it's not an equals to.
Oh.
Okay.
We do the next one.
No.
No, we're not done yet. Okay. Now, is this an above or a below kind of problem?
I don't know.
I don't know.
This is a less than. So this is a less than problem. So is that above or below?
Below.
Below. And if you look at this line, do you think below is on the left or on the right?
The right.
The right is below the line. It's under the line down here. This is above the line. Okay? Now, you're not shading. Stop shading because we're going to shade both at the same time. So right now what you're going to do is you're going to draw some arrows that show we would have shaded this way. Okay, other line. What's the y-intercept of the other line? 3. And then what's the slope?
Up.
Up 1 over 2, up 1 over 2. Going the other way too. Is this one going to be dotted or solid? Dotted. And are we going above it or below it? Below it. Okay, so now the place that we do shade is where both sets of arrows are pointing. So everybody look up for a second, please. Okay? This line we're shading below this one, right? We're also shading below this one. So where do they overlap? Where is both of them shaded? Describe it with your words instead of your finger pointing at the whole thing. I feel like you could. Left and right and up and down, there's lots of words to say stuff.
To the right.
To the right. So like here? What about here? No, that is not. Okay, so it's where both of the arrow sets point. So down here. Okay? All right, I'm going to try one more time with you, and then you're going to try with your partner. All right, example 2. Um, 1/3 x plus 2 is less than y. And this one is x is greater than or equal to -3. All right, I'm going to draw my lines. I should do my math on a separate piece. Hold on. Okay, so I'm going to write it over here. Example 2 was 1/3 x plus 2 is less than y, and x is greater than or equal to -3. All right, so we need to get y equals mx plus b. This one actually already is kind of like y equals mx plus b. It's just the y is on this side, right? So I'm going to take this whole equation and just flip it. So I'm putting the y over here now. Do you see how the alligator is eating the y because it's the bigger one? So when I flip it, the alligator is still eating the bigger one. 1/3 x plus 2. This one's x is greater than or equal to -3. Okay, so let's start with that. Y is greater than 1/3 x plus 2. All right, where should I start for that one?
You go up to
Up 2, and then the slope is 1/3.
up 1 over 3.
Up 1/3. Is it a dotted or a solid line? And it looks like we need to shade where? Above that one. Do you see how it's greater than? So I'm going to draw arrows that show that we're going above it. Now the next one is x is greater than or equal to -3. Does anybody remember what that line looks like? If it's just x and a number? It is a straight line, but is it a horizontal line or is it a vertical line?
Wouldn't it be, yeah.
This one's a vertical one. The y one is horizontal. And here's how you can tell, okay? So if you mark off x equals -3, it's right here. And do you see how here x is also -3, and here x is -3, and down here x is -3, so this is a vertical line. If you had drawn a horizontal line, it would have been on the axis right there. This one's a solid line because it's an equals to. Now, this is the one, literally the one situation where we can't think about the water test about like what's above and what's below. Okay, so which way do you think is greater than -3? To the left or to the right?
To the right.
Exactly as it would be on a